We are starting Unit 6 on force and motion. And our first tech we're going to look at is 6.8a. We are going to compare and contrast potential and kinetic energy. First, let's look at what potential and kinetic energy is. First, energy is the ability to do work or cause change. Energy comes in two basic types, kinetic and potential. Kinetic energy is the energy an object has because of its motion. Potential energy is the energy that results, it's when it's not moving and it gets its energy from its position or shape of an object. So this week we will be talking about different examples of kinetic and potential energy that we see at home and in the classroom and at school. We're going to look at the types of potential energy. First of all, gravity. Gravitational potential energy relates to an object's height or weight. So in this first picture, the blue skier has more gravitational potential energy because he's at a greater height. So they have the same mass, but the blue skier is at a greater height. So they have more potential energy. This simulation, this next picture, the green skier has more gravitational potential energy because they're at the same height, but the green skier has more mass. Elastic potential energy is the energy associated with objects that can be compressed or stretched. The example here is a trampoline. Also, another example would be a stretched rubber band. When you stretch it out, but you don't let it go yet, that is elastic potential energy. So let's look at how they're related. When an object moves, potential energy transforms into kinetic. And then when a moving object stops moving, it's transferred from kinetic back to potential. An object at rest has potential energy but no kinetic energy. So looking at this object as it would swing back and forth, it would have its greatest potential energy at this point and at this point, because it would stop moving just for that split second and have potential energy before it started moving back. Its greatest kinetic energy would be right here. So I want you to think about this question. How do the potential energy and kinetic energy of a ball change as it rolls down a hill? How do the potential energy and kinetic energy of a ball change as the ball rolls down the hill? Let's also look at this simulation of a painter. So we're going to explore how a can of paint can have energy and how that energy can be converted. So we're going to pick one of the paint cans, obviously, by looking at the size. This is telling us that the blue has less mass than the red. So let's select the blue. And then we're going to, right now it has a very small amount of potential energy because of its height from the ground. This is gravitational potential energy. But let's increase the potential energy by making the painter go up the ladder. So now we see that it has potential energy because of its height. So as I click go, we're going to see what happens to the potential energy and then what happens to the kinetic energy at the same time. Let's reset this, and let's do it with the red paint can. So it has more potential energy in the same position because it has more mass. We're going to move our painter up the ladder. Right now this is the highest amount of potential energy. And what we're going to see happen is when I click go, we're going to see the potential energy decrease, because as soon as the painter drops it, it loses its potential energy, and now it has kinetic energy because it's moving. And then once it stops moving, it has potential energy again. But it won't have very much potential energy because it's on the ground. So because it doesn't have the height as it does right now. So let's click go. So we notice that the potential energy went down and the kinetic went up. And now it has, this shows it has no amount of potential energy. We know it does have a small amount because it's not moving. but it's on the ground and it can't fall anymore. So height has a definite relation in how much potential energy. So mass and height is what determines the amount of potential energy. And what we're going to learn this week is that mass and speed is what affects our kinetic energy. So what I want you to do tonight, since watching this video, I want you to think about this question, and I want you to have an answer when you come to class. How do the potential energy and kinetic energy of a ball change as the ball rolls down the hill?